Okay, here we will discuss the K-map. So in introduction part, we can say this K-map as a graphical representation of Boolean function that you can see from this first line, graphical representation of Boolean function. Or we can also define this K-map as a pictorial representation or pictorial method used to minimize the Boolean expressions without use of Boolean algebra. So in here, we will not use any Boolean algebra to minimize the Boolean expressions. Besides that, we will be using some pictorial method. That particular method is called as this K-map, Karnaugh map. So this K-map is nothing but a pictorial method that is used to minimize the Boolean expression without any use of Boolean algebra. In that way also we can define this K-map. And this K-map consists of many cells. K-map consists of many cells. Okay, and this number of cells will be given by the equation. Number of cells in a K-map that is equal to 2 raised to n. Okay, this quantity 2 raised to n, where n is the number of variables or number of inputs that will be given to that particular circuit. Now, if you consider a simple example, if you consider an AND gate with the 2 variables or 2 inputs, then we can say, let's consider these two are the inputs A and B. Okay, these are your inputs. This A and B, and this is your output. Y is your output. So in that case, if you consider 0-0 combination, 0-1 combination, 1-0-1-1 combination, which means that your A is 0, okay, B is also 0, which means you are not applying any voltage at the terminal A and terminal B, because you are having 0 here, or we can say it is a low voltage. For example, if you are applying +5 and +2, then +2 representing the 0 value, okay, which means that it is having low value, and 1 representing high value. So if you are using that AND gate like this, you are having A and B here. Okay, you are having A, this is your B. So if you are applying some voltage at this junction, for example, if you apply some +5 volt, which means that it is in one state, high state. Okay, if this voltage is minimum or which is 0, then we will be having which is equal to 0. For example, your B is let's say at some 0 potential, then correspondingly your B value will be also 0. Or if it is at +2 potential, which is less than this value, +5 value, then also this will be denoted as 0 in the binary form. Okay, so one is high, the other one is low. High means 1, low means 0. So when you are giving here 1, which means that your terminal A is at high potential as compared to B. Okay, so when you are having these different combinations 0-0-0-1-1, 0-1-1, okay, correspondingly we will get some output here. Okay, so now you are having for example, this case A dot B will come here, so this is 0-0-0-1, that is your output. But you can see that there are two variables here. Two variables here, they are A and B, they are the inputs. So we are having n equal to 2, a number of variables that is equal to 2. So that we need 2 raised to n, which is 2 raised to 2 equal to 4 cells in that case. So if you are having any system with the 2 variables, then we need 4 cells in your K-map. So this K-map will be looking like this. Okay, so we need 4 cells basically. We need 4 cells, and you can take your A, B values either top or bottom of this line. So you can consider it like this, or you can take your A value here and B value here. That is also not wrong. So both are relevant. Now, if you consider A and B 0 and 1, for example, in this case it is 0, here it is 1, here it is 0, this is 1. So in this cell, what will be the value of AB? This cell will be 0, 0. AB if you're representing 0, 0. Then this one, it will be 1, 0. If you're representing AB, I'm talking about AB. And if you're representing AB here, then it is 0, 1. If you're representing AB here, then it is 1, 1. And each of these 0, 0, 1, 0, 0, 1, 1, 1 representing the address of each of these cells. Okay. Now, if you convert these binary values into decimal, then 0, 0 will be nothing but your 0 in decimal. Okay. And what is 1, 0? 1, 0 is nothing but 2. Right. And how this is coming? Because you have to, in case of 1, 0, I will say, so you have to multiply 0 into 2 raised to 0 plus 1 into 2 raised to 1. Okay. And this will be giving you 2. So this is how we will convert binary number to decimal system. And if you consider 0, 1, 0, 1 is nothing but 1. You can do the same procedure, put 1 here, 0 here. Okay, so 0 here, 1 here, then you will be multiplying this 1 with the 2 raised to 0. So 2 raised to 0 is 1. 1 into 1 is 1. Here it will be 0. So total output is 1. Similarly, we are having the last one, 1 into 1, 1. 1, 1 is corresponding to 3. So in that case, we will be having 1 here. So this is equal to 2 plus this term is 1. So 2 plus 1 will come. So this will convert that binary number to decimal system. So those who does not know this binary to decimal conversion, you can go back and check in your degree classes, the textbooks. You can also check that principles of electronics by Canada. So these basics are there. Okay. Anyway, so this will be this number. If you are saying these numbers for the cells, then this is nothing but 0. This is 1. This is 2. This is 3. So these all representing the address of these cells, each of these cells. Now you can also make this map with 2 variables, which means that we will be having 4 cells. So you consider it like this. And if you take A in this side and B in this side, okay. So here A is your most significant bit, B is your least significant bit, because A will be giving the high position. Okay. B will be giving the lower position. If you consider any of these combination, okay, and this side will be the most significant bit because it is multiplied with the 2 raised to 1. This side it is least significant bit because it is multiplying with the 2 raised to 0. So 2 raised to 0 means 1, 2 raised to 1 is 2. So this is the most significant bit, which will be giving the highest value. And this one is least significant. So you can change that most significant and least significant bits above or below this line. It will not change your result. So in this case, if you consider B0 here, B1 here, 0 here, 1 here, A0 here, 1 here. So if you consider this case also, we'll be having here 0, 0. Here we'll be having 0, 1. And here 1, 0. And here 1, 1. If you represent AB. Okay. So in that case, if you calculate what is the corresponding decimal values, then we will be getting this one is 0, this one is 1, this one is 2, this one is 3. So this 1 and 2 will be interchanged in that case. Addresses. Okay. But that will not change your result anyway. So these both representations are valid in all the cases. If you consider third variable, fourth variable, it does not matter. You can consider most significant bit and least significant bit either on the top or bottom of this particular line. This one. Okay. Now, if you consider third variable or 3 variable system, not third variable, it is 3 variable system. If we consider, three variable, what is that number of cells? Number of cells will be equal to 2 raised to 3, that is 8. 2 raised to 3 is 8. Now we have 8 cells, number of cells which is equal to 8. So the you can consider it different way. I will show in both cases, both ways how we can draw this one. So let's first let's consider it like this. So we need 8 cells in this case because we are having 3 variables. Okay. Now 3 variables means we need A, B, C. 3 variables means A, B, C. So first we'll consider, we'll write A, B this side and C here. Okay. So now what will happen? This is 0, 0. This 0, 0 means A equal to 0, B equal to 0. 0, 1. A equal to 0, B equal to 1. Then after that we have 1, 0, A equal to 1, B equal to 0, then 1, 1. A equal to 1, B equal to 1. Here C equal to 0, C equal to 1. Now one more thing that you have to remember is that this address position that we represent by 0, 0, 0, 1, 1, 0, 1, 1, that follows gray code. Okay? And in this KMAP, as it is following the gray code, in KMAP, the adjacent cell, adjacent cell, adjacent, adjacent cell differ by adjacent cell differ by 1 bit. Adjacent cell differ by 1 bit, which means that when you consider this cell, it should be different from this cell with 1 bit. Only 1 bit difference should be there. Okay. So if you consider these two, let's consider these two first one. These two cells, if you consider, okay, these two cells, if you are considering. So these two positions corresponding to this AB, address AB, that address will be 0, 0 and 0, 1. So what has happened? What has happened here? Here 0, there is no change. 0 just we have taken from the previous cell. But here this 0 is changed to 1, which means that we are having change of 1 bit. Only 1 bit is changed. Okay. Similarly, here also you can see this 0 is changed to 1. So if you consider the adjacent cells, they should be differed by only 1 bit. But when you consider this one, what has happened here? This 0 is changed to 1. This 1 is also changed to 0. So both these bits are changed. Both of these bits are changed. So this is not allowed. Only 1 bit has to change from that one cell, the neighboring cells if you consider. So in this case, 0 changed to 1, 1 changed to 0. So 2 bits are changed here. So this is not allowed. So we have to modify this address of this particular cell in such a way that this 1, 0 will be coming here and 1, 1 comes here. Okay, now what happened? If you consider now, what is the change? This 0 is changed to 1. This 1 is remaining as it is. So only 1 bit is changing. Now it is okay. Here also this 1 is remaining as such, and this 1 is changing to 0. So only 1 bit is changing from the previous one. Okay. So this has to be followed in all the KMAP when you are drawing the KMAP for simplification. So first one is 0, 0, 0, 1, then 1, 1 will come first, then 1, 0. Because in KMAP, adjacent cell differs by 1 unit or 1 bit. Okay, So this here we can write this 0 0. So the address will be first one 0 0 0. Okay, ABC. I'm writing ABC here. Previously in 2-bit I wrote AB. Here I have to write ABC. Here we wrote AB, AB values. Okay. Here I have to write ABC value. So AB here it is 0 and C is also 0. So ABC will be equal to 0 0 0. And in this case AB is again 0 0, but C is 1. C is 1. So A 0 0 1. Here AB is 0 1 and C is 0. So this is 0. And again AB is 0 1, C is 1. So this one. Here AB is 1 1, C is 0. Here AB is 1 1, C is also 1. And here we have 1 0 0 1 0 1. Now if you convert these values into decimal points, you can do it by using the aforementioned equation. Okay, what you have to do, for example, if you consider 0 1 1, let's consider that for those who don't know about it. So if you are having 0 0 1, how we will convert this binary number to decimal number, something which is in base 10. So here we have to convert this 1 into 2 raised to 0 plus, then this is the position value 1, this is position value, this is the value in that position, and this is 0 into 2 raised to 1 plus 0 into 2 raised to 2. So these zeros I have to expression. So this is equal to, these two terms will become 0. 1 into 2 raised to 0 is 1 itself. So 0 0 1 is 1. So this is 1. Similarly, you can calculate all other values, and then we'll get this one is 0, this one is 1, this is 2, this is 3, and this one is 4, this one is 5, this is 6, this is 7. So don't make any mistake here. So this is 0, 1, 2, 3. Then 4 will come at the last row. Okay, this one. 4, 5, then 6, 7 comes here, because we have changed this 1, 1 to this position. Similarly, this K map again we can draw like, can also draw this K map like this. Also allowed. There is nothing wrong with this. So we can draw it like this also. No problem. So we need 8 cells. 8 cells are there. Now what will happen? You have to consider AB here. In this case, we are considering here AB in the top and C here. So we will be having C 0 here, 0 1 here, and AB is 0 0 0 1 1 1 1 0. Now, if you consider these values, then what is this? A, B, C, you have to consider 0 0 0 0 1 here AB. So 0 1 0 1 1. So 1 1 0 1 0 1 0 0 ABC value. Here 0 0 1 C is 1 here. 0 1 1 0 1 1. Then 1 1 1. Then 1 0 1. Now if you convert that into decimal values, how will come? This is 0. Okay. This is 1. This is 2. This is 3. This is not 4. This one is 4. This is 5. This is 6. This is 7. So this is how we represent the address of each cell. Okay. So don't make any mistake in this two. Okay. 2, 3 comes here. Then 4 will come at the last row. So 4, 5, 6, 7 will come here. Similarly, you can also can also do the 4 variable can app. It's a 4 variable. The 4 variable means what? 4 variable means number of cells will be number of cells. Number of cells will be equal to 2 to the power 4, which is equal to 16. So we need 16 number of cells in this. Okay. So if you draw that, then it will be like this. So I'm drawing it very roughly, so the drawing will not be that much good. You can draw it neatly in your book. Then we have, okay, so we need 16 cells. So 4 into 4 will come, right? So this one is first column. Similarly, this way also. So this is 16 cells. This representation for 16 cells. And now we'll consider AB here and CD this side because we need 4 variables. 4 variables means A, B, C, D. Now again, as we discussed before, how this will come? Addresses. Addresses are AB equal to 0, 0. So this one is 0, 0, 0, 1, 1, 1, 1, 0. As we discussed earlier. So this is 0, 0, 0, 1, 1, 1, 1. Okay, so first one is 0, 0, 0, 0, 0, 0, 0. Second one is 0, 0. Sorry, this one is 0, 1. Okay, because this part is 0, 1. Maybe we had to write first. So 0, 0. Then 1, 1, 1, 1, 0, 0. Then 1, 0, 0, 0. So this column representing 0, 0 first, right? So 0, 0, 0, 0, 0, 0. This column representing 0, 1 first, 0, 1, 0, 1, 0, 1. Similarly here 1, 1, 1, 1, 1, 1, 1, 0, 1, 0. This row representing 0, 1 at the last. So this is 0, 1, 0, 1, 0, 1, 0, 1. This row representing 1, 1 at the last. So 1, 1 comes like this. And here 1, 0, 1, 0. Now what is the value? Decimal value? Decimal values. Decimal values here 0, here 1. This is not 2. This is 3. So this is 2. This is 3. Okay. Then this is 4, 5. This is not 6. This one is 6. This is 7. This is 8, 9. This is not 10. Okay. Oh, sorry. This I did the mistake. This is not 8. Okay. This is how we will make mistake. So this one should be 8. Okay. This is 9. This is 10. This is 11. This one is 12. And this one is 12. This one is 12. This one is 13. Okay, 1 minute. Okay, so this one is 50. This one is 13. Okay, then this one is 14. This one is 50. So this one representing 12, then 13, okay, then 15, 14. This is 14, this one is 15. Okay. You can just convert these values. This 1100, that will be corresponding to 12. You can check that here. So for 110, what it will come? 1100. I'm talking about this cell. Okay. So 1100 means 0 into 2 raised to 0 plus 0 into 2 raised to 1, 2 raised to 1 plus 1 into 2 raised to 2 plus 1 into 2 raised to 3. So what is this value? This is 0. So 0 plus this is 0. 0 plus 2 raised to 2, 4. 4 into 1 is 4 plus 2 raised to 3, 8. 8 into 1 is 8. So total will be equal to 12. So this is how we calculate addresses. The same cell, the same 4 variable K map, or we can say the these 16 cells that we have drawn here, that can be again, you can represent like same 4 variable I am saying. So this one is first column. So this is the first row, second row, and this one is the third row. And you can represent the most significant bit below. This is the most significant bit that is coming in this side. You can see. So that I can represent here and CD here. Okay, in this time, what will happen? You're having those 0, 0, 0, 1, 1, 0, 1, 1 here, 0, 0. So okay, so we have to write 0, 0, 0, 1, 1, 0. Sorry, one not. It should not be 1, 0. 1, 1 here comes, and this is 1, 0. So I'm making same mistakes. That mistake. So this is 1, 1 and 1, 0. So this one is 0, 0, 0, 0. Okay, and this you can see AB is here. So this row will be 0, 0 now. 0, 0. Here it is 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0 in all these rows, on the, all these cells in the same row. And in the same column, we have 0, 0, 0, 0, 0, 0. Here, this entire column will be having 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Here it is, entire column is 1, 1, 1, 1, 1, 0, 1, 0, 1, 0. Now, if you calculate the position and can convert these values into the decimal, then this will be 0, this will be 1, this is not 2, this one is 2, this is 3. And this one is 4, 5, 6 comes here, 7 comes here. 8, not this way. This is 8, 9, 10 will not come here, 10 is this, 11. Now this one is 12 again. This one is 13, 14 comes here, 15. Okay, this is how we represent the addresses in the different K maps that we discussed. Now we will discuss the filling K map, filling of this K map. So So filling of K-map, or we can simply write filling K-map. This K has to be capital. Okay. Filling K-map. How we can fill K-map? So there are two ways. One is by using the SOP form. The second one is by using POS form, POS form. So SOP form means sum of product, as you know, sum of product. What is POS? POS means products of sum. Products of. Now, sum of products means something like, as you know, this is like AB plus BC plus CD. Which are the products? These are the products A, B, B, C, C, D, which are their products, and they are summed. Okay? This is a summation of the products. There are different product terms, they are summed. Here we have product of sum, that is A plus B into B plus C into C plus D, like this. So this is product of sum. So this is taking product of each of these sum values. So these are the different scenario. And in SOP, you have to remember in SOP, a 0 means A bar and 1 means A. So if you are having a variable A, and in SOP, A means 1. A bar means 0. That you might have learned from your degree classes itself. This SOP, post, midterms, max time, all those things. So here, let's consider the second case, POS, product of sum case. Your 0 will be A and your 1 will be A bar, just opposite to the post form. Sorry, SOP. So SOP, in SOP, 0 is A bar and 1 is A. In POS, that is product of sum form, 0 is A and 1 is A. Now let us consider the K-maps again. So we have, first we'll consider the two variable case. So we have two cells and we have variables A, B, because it is only two variables, so only two variables have to represent. So let's consider this is your A, this is your B. Now what will happen? This is 0, this is 1, this is again 0, this is 1. So here, if I am using POS form, if I am using SOP form, sum of product, my zeros are representing by A bar. So here this 0 means this is A bar. This 0 means this is B bar. 0, here it is B bar, this is A bar. Why? If you are using SOP form. So that we can write this address as A bar, B bar. Now what is this 1? 1 in case of SOP, that is A. In this case it is B. Here this one is A. So there is no bar here. Okay, so this is 1 and this one is 0. A is 0 here. So that we can say this one is A bar B. And if you consider this cell, the third cell, then we can say this is B equal to 1 because here it is 1. So this is, this is A. So this is 1. So this will be A. In SOP form, 1 means A. Or whatever the variable that as such. There is no complement or there is no bar for that way. If your value is 1. So here A will come and here we are having B equal to 0, which means that B bar. So this is B bar. Then we have finally A into B. So this is the filling or representation of different variables inside each cell when you are using SOP form. Similarly, you can arrange the you can fill in the four variable K map also. I'll just draw that. Take some time to draw this thing. So if you consider four variable, just consider drawing is not that much good. Anyway, so this is a four variable K map. I am representing AB here, CD here. Okay. So as you know, the values 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. What will be the addresses in terms of if you are using phosphor? Then this is nothing but A0, B0. So A bar, B bar. C0, D0, C bar, D bar. Here, both A and B are 0. A bar, B bar. C and D. C is 0. So C bar. D is not barred because D is 1 here. Here again, A bar, B bar because A, B are 0 in this entire row. And C, D which are now 1. So we can write it as C. Then after that we are having A bar, B bar. C into D bar because D is 0. Same way you can write all those all other values. So here we will be having A B bar because A bar B. That should be A bar B. Because A is 0. So A will become barred and B is as such. And then we are having C bar, D bar. So in this entire column, we are having first two terms as A bar B. So entire row, A bar B, A bar B. And this entire column, if you consider there, you have C bar D as your last two terms, C bar D. Here also C bar. Here we have the last two terms as CD, CD, CD. Here CD bar, CD bar, CD bar. Here we'll be having A, B, C bar, D bar. Here also we'll be having A, B, A, B, A, B because it is representing 1, 1. Both A and B are 1. And here we'll be having A, B bar, C bar, D bar. Then also A, B bar, A, B bar, A, B bar. I hope you understood this concept clearly because that is needed when you are going for this simplification. This is how we will fill in each of these cells when you are considering SOP form. Now, if you consider post form, that is when you are having one that is representing A bar. Okay. So in post form, if we consider the same scenario, in post form also we will be replacing that dot product with plus or product or symbol as you can see from here. That is the products of sum A plus B, B plus C, like that. So this dot is converted into plus here. So in each of these cells, what will happen? Okay, so we will just represent in the same way. For the case of post. So we are having 2 by 2 K map here. So in post form, what is 0? 0 means A. 1 means A bar in post. Here 0 means B. This is B bar in post. Product of some form if you are considering. So in that case, this will be, this is 0, this is 0, so A plus B. Here, this one will be A plus B bar. This one is A bar plus B. And this one is A bar plus B bar. So this is how that will be changed when you are using post. There you will be having A plus B. Or you can say that is A or B, A or B bar, A or A bar, that is the correct representation. A or B bar, A bar plus B, sorry, A bar or B, A bar or B bar. Now similarly, we can do the same for 4 by 4 K-map, that is this one, 4 variable K-map. This all that is this dot eraser is not that much because it is erasing many lines. Almost all I have to do. So let's consider that 4 by 4. So in post form, I'm saying in post form. So this is representing A, B, and C, D. And what will happen here? So this 0, 0 representing, what is that? 0, 0. 0, 0 representing C plus D here. Okay, I should write something different here. So because in post form we'll be having some different scenario here. In the first case, it is not a problem because only one variable we are having on both sides. So here we have to write 0 plus 0 okay, in this side. Okay, what is that? C plus D. 0 plus, so this is C plus D. C plus D. Then we have C plus D bar. What is that? So this is 0 plus 0. This is 0 plus 1. That is 0, 0, 0, 1. Okay, then 1, 1. That is 1 plus 1 in this case. 1 plus 1 means C bar plus D bar. Because C representing 0, C bar is 1. Similarly for D bar also. And here 1, 0, 1 plus 0. This is nothing but 1 is for C bar plus 0 D. This is a cost. Similarly here also we have A plus B, A plus B bar, then A bar plus B bar, A bar plus. Now if you fill in this cells, then we need a little white cells here. So what is this term? This term will be A plus B plus C plus D. Okay. Then here A plus B plus C plus D bar. Similarly, you can fill all these cells. In the next one, A plus B bar, here C plus D. Here A bar plus B bar or A bar or B bar for C or D. Here A bar or B or C or D. So this way you can fill all those cells and just give you that as a number. You can complete that A plus B bar plus and so on for all these cells. So here that dot will be replaced by plus or symbol, okay, in case of post form. Also when we are minimizing, the Boolean expressions, then there we can also see that we have to use zeros instead of 1 when you are using this post form. That we will discuss in that. So this is how we will fill the cells, okay, in CAMAP for different variables. Now we will discuss about how we'll represent this CAMAP. That is the representation of CAMAP. This representation of KML. Okay. Let us consider a truth table. Let's see. Let's consider three variable system. Three variable. So we are having inputs A, B, C. Okay, and output Y. So A, B, C will be having, these are having values. Let's say 0, 0, 0, 0, 0, 1, 1, 0, sorry, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Correspondingly, we are having output 0, 1, then 0, 0, then 1, 0, 1, 1. So these are the output for each of these different combinations of input. So if you are giving A0, B0, C0, you'll be getting output as 0 for this particular circuit. And if you consider, let's say 1, A equal to 1, and B equal to 0, C equal to 0, which means that you are applying high potential only at the A terminal. Then you will be getting output as high voltage. Okay? Some logical expressions with some logical expressions for logical operations which is happening inside that circuit, and we are getting output like this as well. Okay. Now, if you use a truth table like this, then we can also represent these outputs in that particular camera. So if you consider this case, we are having three variables here. Okay. So three variables means you have will be having KMAP like this. Right. So we'll be having KMAP almost like this. So here we need 8 cells total because you are having three variables. Three variables means 8 cells. Now we have 1, 2, 3, and 4. So this is AB, and this is. So I am considering post from here. Or let's consider SOP form, SOP form, SOP form. So in SOP form, we can write this as A bar, B bar, is nothing but A bar, B bar, because 0, 0, and 0 in post SOP form, which is A bar. So A bar, B bar, A bar, B, A, B, A, B bar. Then we have C bar here and C. Now, if you fill all those values inside this cell, you can easily see that this is nothing but A bar, B bar, C bar. This cell, first cell I am saying. This cell is nothing but A bar, B bar, C bar. So what is that A bar, B bar, C bar in this truth table? It is nothing but this one. Because 0, 0, 0 representing A bar, B bar, C bar. Because A, B, C will be representing in SOP, A, B, C will be represented by 1, 1, 1. So A bar, B bar, C bar means 0, 0, 0. So this particular cell is 0, 0, 0, and there you are getting output at 0. So in this cell, we will be having output which is equal to 0. Next cell, if you consider A bar, B bar, C. What is that? A bar, B bar, C means A bar is 0, B bar means 0, B bar is also 0, C is 1. So this term, second one. So this cell is representing this second one, so that it is output is 1, like you can see here. So that output is you can represent like. Similarly, you take all other values. If you consider this one, this is 0, 1, 0, which means that A equal to 0, which is A bar. B here it is 1, so B. C is 0, so C bar. So it is representing A bar B C. So A bar B C is this third one. Correspondingly, we have output which is equal to 0. A bar B C. Let us consider A bar B C. Right? So A bar B C means A bar B C, this one. A bar B. I think, sorry, A bar B C bar we have to consider here because C is 0. Here C corresponding to C we have 0 here. A corresponding to A we have 0 here. B column we have 1. So A 0 means that will result in A bar. This is B. This is C bar. So A bar B C bar. So this will be that particular cell. A bar B C bar. In this row, this column. A bar B C bar. So this one will be output is 0. Similarly, if you consider all other values, then we can easily write all the outputs in this. But remember that these two columns, when you calculate, you have to be careful because this is ABC bar and ABC bar comes this one. ABC bar is nothing but this particular combination. So here it is 1, here also 1, then 0. So A, B, C bar. So this is corresponding to this particular value, 1. So this is 1. Similarly, ABC. ABC is coming the last one. Then come these two values. Okay. So last one is also 1. So I will write here also 1. Then we'll be having A, B bar, C bar. That is A here, B bar, C bar. So that is this is also 1. The next one is. So this is how we'll represent the output in KML from the truth table. Okay. The same way, the same thing we can represent in some other form. We are considering sum of products. Let us consider you have some output y equal to A, B, C bar plus A bar B C, A bar B C plus some, let's say, A, B bar, C bar plus A, B, C. So this is just representing an output y as just like as this. Okay, so I just converted that into SOP form corresponding values. Just time by. So we are having this output y, and this output will be equal to 1. That's how we'll calculate all these values, these terms. So if you want to represent this, how we will represent this in SOP form by using that min terms. Okay, so we are having product of sum. Sorry, so sum of products here, SOP form here. Okay, so what is this A, B, C bar? That is first you have to consider. A, B, C bar. What is this? This is A means 1, B means 1, C bar means 0. What is this value? This value will be equal to, if it is 2 raised to 1, 2 raised to 4 will come, 4 plus 1, 4 plus 6, right? This one is 6. And then this one is 0, 1, 1, 0, 1, 1. and that will be giving you value which is equal to 3. And this is a equal to 1, b bar is 0, c bar is also 0. So this will be giving you 4, okay, 2 square. And this one is 1, 1, 1. So this is giving you 7. I will be representing y will be equal to m6 plus m3 plus m4 plus m7. In simpler way, we can represent this as sigma small m, that is corresponding to minterms, summation of minterms, and these minterms are which are the positions 3, 4, 6, 7. So this is how we'll represent the corresponding output in terms of in such a way that by using that minterms in the positions of that camel. So we have 1 in third cell, 4 cell, 6 cell, and 7 cell. So if you represent this output in this particular three variable K map, then how we will be representing that? In that case, we will be using very good. So how we will represent that in this K map? So third cell, which one is third cell? This is one, as you know, this is the first cell. Which one is second? Second is A bar, B bar, C. So this, sorry, this is 0, this is 1, then this is 2, this is 3, and this is 4, this is 5, this is 6, this is 7. This one is 7. So third one is this one, this cell. So that third one is having value which is equal to, third cell is having value which is equal to 1. And fourth cell is this one, this is also equal to 1. And sixth one, this one is also 1, seventh one is also 1. So this is how we will represent the particular question by using camel. In the same way, you can also represent things in pose form. Okay, so let's consider that. I will just erase this SOAP form now. So if you consider pose form, how it is going to change, that we'll discuss. So in pose form, I am saying. So for example, in pose form, you are having output y equal to a plus b plus c into a plus b bar plus c bar into, then we have a next term, let's say a plus b bar plus c into a bar plus b bar plus c. So this is product of sum, products of sum. So there are many sum terms here. They are product. They are taken product of each other. So a plus b plus c and other terms, which you can see from here. And if you calculate what is the values corresponding to these terms in pose, okay. So a in pose, a means 0. Okay, so this is 0 plus 0 plus, or you can write it as when you are considering that equations, you can write it as 0 0 0 0 0 0. This one is 0, b bar is 1. Okay, if it is bar, then it is 1. So c bar is 1. A is 0, 1, 0. This one is 1, 1, 0. This is in pose form. A bar or b bar or c bar, which is equal to 1. A, b, c, which are 0. So this is 0, 0, 0, 0, 1, 1, like that. You can see from here. So this is nothing but 0. This is nothing but 3. This is nothing but 2. This is 4 plus 2, 6. So in this time, y will be equal to m 0, 0th max term capital M into, we are having into here. Previously we are having plus, instead of that we are having into here. So this is M0 multiplied with M3 multiplied with M2 multiplied with M6, or M0 and M3 and M2 and M6. So this can be represented as y equal to, if you are having this as your max terms, then pi of capital M, okay, or sometimes you can write it as full also. That is just these are just representations, so don't confuse with that. So in case of max term, we will be having capital M, and in min terms, we will be having small m. So here we are having 0, 3, 2, and 6. So here you can write it as directly 0, 2, 3, 6, 2, 3. So these are the positions where you are having zeros. So when you are considering that uh, host form, then you have to represent each of the cells as zeros. So in this case, if you are using the same CAM map with 3 variables, then we can represent this expression as this one I am saying. So this can be represented as, in these positions we will be having 0. So in 0 we are having a 0, and in 2 we are having next to 0. In third cell, that is here, that is 0. 6 also we are having 0. So this is how we represent the CAM app for SOP and POS forms. Okay, so I hope we will, I think we will finish here. Okay, and we will continue in the next class, same simplification of Boolean expression using CAM app. And we will be discussing about how we can simplify expressions by using this CAM app. So from next class onwards, we will be starting that simplification process. This is the basics. These are the basics of this CAM app that we have discussed today, what we discussed today. So if you are having any doubt, then you can ask. Otherwise, we can just wind up here.